it's a trim-looking craft you're piloting. How's she handle?
Like a dream. I've never enjoyed any car so much. And this automatic top is so easy to operate. All I do is move the knob on the dash, and I'm protected in a squall.
Yes, at work or play, all eyes are on the fashion car of the year. No wonder it's the envy of us all. But wait a minute. The luxury of an automatic top is swell for the lucky owner. Well, what does it mean for the guys on the service floor?
Every time I think I'm getting somewhere in this business, they spring something new on me. Golly, I wonder if I can find my way around on this job.
Oh, don't be a pessimist, Art. It isn't as tough as you seem to think. Considering the job it does, the top operating system's pretty simple after all.
Well, maybe to you. All I know is I move the knob on the dash and things happen. But what gives with the gadgets under the hood?
Well, let's take a look. Now, see, there aren't enough gadgets, as you call them, for you to go getting scared about them. The controls are all mounted here on the dash panel. The control rod on the dash hooks up with a control valve on top of the pump motor, and that's what makes things happen. The rod moves the valve lever, and two things happen at once because the control is a two-in-one device. It's both a hydraulic and an electrical control. Hydraulically, it's a selector valve that sends the fluid into the correct line. And electrically, it's a switch that controls the solenoid on the side of the motor. The solenoid starts the electric motor, and the motor drives the pump, which pushes the fluid out through the lines to the double-acting cylinders located back of the quarter trim panels. The cylinders operate the linkage and move the top up or down. Now, isn't that simple?
Oh, you can always make anything sound simple. But what happens when...
Of course, Fred couldn't tell the whole story in those few words. He didn't mention, for instance, that there's a circuit breaker for safety, or that the whole top is designed so that any mechanic can keep it ship-shape easily. But he did get across a point that all of us should know about. The power system for the top is really a simple substitute for human effort. Its electrical system is its brain. Its hydraulic system is its muscle. And its mechanical system is its skeleton. So let's talk about each of these systems separately and how to keep it in top operating condition. Checking the electrical system begins with testing battery condition, and as in any kind of electrical check, should include all wiring and connections. Since movement of the control rod operates the switch contained in the control valve assembly, the rod must be set for correct travel. For example, when the control rod is pushed in to lower the top, the switch must close before the knob hits the bracket. To assure positive contact, adjust the control rod travel so that there is 1/8 inch between knob and bracket when contact is made. If the top will not operate, any unit in the electrical system may be at fault. To check the system, hook the diagnosis test set to the battery, in the same way as for testing the starter motor. Operate the control switch and check amperage draw. A normal reading is between 120 and 140 amperes. If the reading is seriously low, a step-by-step check of the system will locate trouble. Test the solenoid with a jumper wire between the battery lead and the center terminal. A clicking sound indicates satisfactory operation. No click means the solenoid must be replaced. If the motor does not operate even when a click is heard, short across the large terminals with a wire of battery cable size. If this starts the motor, the solenoid is defective and must be replaced. But if this still does not start the motor, it is the motor which is defective and must be repaired or replaced. The electrical circuit from the battery through to the switch can be tested with a voltmeter. Ground the positive lead and then touch the negative lead at the following points. First, at the input terminal of the circuit breaker behind the instrument panel. Second, at the output terminal of the circuit breaker. Third, at the input terminal of the control switch. And fourth, at the output terminal of the switch. On this last test, operate the switch by hand. Each reading should be 6 to 7 volts. If a drop in voltage is observed between any 2 points, the parts concerned must be replaced before the checks are continued. Checking the hydraulic system begins with the fluid supply. Inspect the condition and level of the fluid. If necessary, clean the reservoir, wipe it dry, and add recommended brake fluid to bring to the level mark. Operate the top several times in each direction to clear air from the lines. Leave the top either all the way up or all the way down, so the weight of the top will not force fluid out when lines are disconnected. To test fluid pressure in the pump, install a gauge on the pressure line going to the control valve. Operate the control rod. Pressure throughout the system should be between 250 and 260 pounds. Now, this pressure is regulated by the relief valve, as will be explained later. To test pressure at the control valve, disconnect both operating cylinder lines. Install the gauge at one valve port and plug the other. Operate the valve to get a reading. Repeat the test at the other port. If the pump and valve pressures are normal, pressure in each operating cylinder may be checked. First, put the top all the way down and remove the rear cushion for access to the T. Disconnect one upper cylinder line at the T and plug the open line to prevent loss of fluid. Install a pressure gauge in the T. Push the control rod in and check the pressure. Low pressure indicates a leak in the opposite cylinder. Repeat the test on the other cylinder. If both readings are low, a leaking cylinder or damaged line is indicated. Checking mechanical operation is, of course, a matter of visual inspection. Watch for binding or misalignment. The top should fit snugly at all points and move up or down easily. If any of the checking procedures we have been talking about reveal the need of maintenance, this is not difficult to do. Parts such as the solenoid, the valve and switch assembly, and the operating cylinders should not be taken apart and therefore must be replaced as units. Before doing anything to the hydraulic system, disconnect the battery to prevent accidental operation. If you are replacing the valve and switch assembly, disconnect the lines from the pump and the lines leading from the valve to the operating cylinders. Then disconnect the wires and the control rod. Remove the screws holding the valve to the supporting bracket and remove the valve and switch assembly. When installing the new valve, be sure to set the control rod for correct travel. Operate the top several times to clear air from the lines and fill the reservoir to the level mark. If you have to replace an operating cylinder, be sure the top is all the way down before you start. Remove the quarter trim panel, disconnect the hydraulic lines, plug them, and remove the pins at the top and bottom of the cylinder. Then lift the cylinder out. Before installing the new cylinder, be sure the piston rod is in the down position and the cylinder is filled. After assembly, operate the top and check the connections for fluid leaks. Refill the reservoir if necessary. If removal of the pump and motor assembly is called for, disconnect the lines and wires and remove the self-locking nuts from the upper and lower mounting brackets. It is not necessary to remove the brackets. Simply push the assembly toward the dash panel to disengage it from the upper bracket. Tilt to clear and lift. To disassemble the pump from the motor, remove the 4 screws which hold the pump to the motor. Lift off the pump, leaving the armature in the motor. Remove the diffuser and baffle from the ends of the inlet tubes by taking out the screws which hold them together. Take out the screws in the pump bottom plate and remove the spider spring. Hold the pump housing upright and drop out the rotors, port plate, and sealing disc. Handle the sealing disc with care. Next, remove the relief valve plug, washers, and spring. Be sure to notice the number of washers behind the plug, because these washers control the pressure in the system. Removing washers will increase pressure. Adding washers will decrease pressure. Now, this special tool makes it easy to remove the pressure relief valve. Inspect the condition of the sealing disc and port plate. If worn or grooved or damaged in any way, they must be replaced. The port plate must also be replaced if its tab is damaged. Damage to these parts is usually the result of worn rotors. Inspect the surfaces of the pump rotors. If there is any wear or pitting, both rotors must be replaced. For best results, also replace rubber seal, port plate, sealing disc, and spring. Thoroughly clean the pump housing with alcohol or carbon tet. Make sure the vent holes are open and blow out the passages with compressed air. If the pump housing is cracked or if threads are stripped at either of the ports, it should be replaced. If fluid has been leaking into the motor, a new pump housing must be installed, because a leak is usually the result of a worn bearing surface in the housing. For this reason, the seal is not available by itself. We won't go into servicing of the pump motor because it is very similar in construction to the starting motor and is repaired in the same manner. The pump housing must be assembled to the motor with the relief valve plug to the rear or opposite the solenoid. Assemble the port plate with the tab seated in the slot in the pump housing. The inner rotor must be installed with the flat visible. The rotors must seat flush with each other and with the sealing disc. Always use a new rubber seal between the pump housing and the bottom plate. After installing the pump and motor assembly to the dash panel, check the pressure at the pump by operating the control valve. Connect the lines, operate the top several times, and check all connections for leaks. Then check fluid level in the reservoir and refill if needed. And now, while the operator turns the record, let's check off the things we've covered so far. We've seen how the top works, how to check it, and how to replace or repair the units in the electrical and hydraulic systems. Let's talk next about mechanical adjustments. Visual inspection will reveal whether there is any binding of the linkage. This can be corrected with penetrating oil or by straightening or replacing links. Just be sure they're okay before trying to line up the top. The header bracket may be adjusted to take up slack in the top between the header and the number 1 bow. Pry the front weather stripping out of the retainer on the side rail. After the weather strip and retainer have been removed, loosen the 2 adjusting screws in the bracket. Do the same on the other side. Move the header forward till all slack is taken up. It may be necessary to drill new holes for the forward weather strip retainer screws. The side rails must provide a level channel for the top of the window. Sagging or bowing may be corrected by adjustment of the stop screw on the rear side rail. If adjustment of the stop screw does not correct the condition, it's necessary to adjust the balance link. First, raise the top at least 10 inches above the windshield to take strain off the balance link. Then loosen the balance link shoulder bolt. It's not necessary to remove trim. Slide the link about a 1/4 inch in the slot and tighten the bolt, making sure the serrated nut is properly seated. Again, check the side rails and repeat the adjustment if needed. Readjust the stop screw so it just touches the control link. Binding of the top edge of the quarter window with the pillar rail weather strip as the window is raised or lowered can be corrected by adjustment of the main pivot bracket. First, draw a line on the window regulator panel from which to measure the amount the bracket is lifted. Loosen the bracket, raise it to lift the pillar rail, and secure the 3 forward screws only. Next, measure the distance from the line drawn on the regulator panel to the same point on the bracket in its new position. Shim the rear of the bracket the same amount. Then tighten the 2 rear screws. Loosening both main pivot brackets permits shifting the entire top for alignment. In doing this, be careful not to disturb the up and down adjustment of the bracket.
Well, we've checked over the brains, muscles, and bones of this job. What's next? A little makeup on the skin?
Yes, we are going to take a closer look at the top fabric, but before we do, raise the windows and you'll see if there's anything to do first.
Say, that's right. Moving the top around could throw out the window adjustments.
That's right, Art. You've got to make sure all the windows have a snug fit at all points for a job that's tight in any weather. Now, here's how I check them. I stick a small piece of paper between the weather strip and the window frame. And if I feel a definite drag when I pull it out, I know it isn't going to leak.
Just how many points do you check then?
I check both top ends on this door window to see that it's parallel with the side rails. Then I check the 2 sides to see that they're parallel with the division bar in the quarter window. You see, Art, how one adjustment affects another?
Yeah, I sure do. If you moved the vent toward the weather strip, that'd pull it away from the door glass. Same thing on the quarter window. It's got to fit the weather strip and still be parallel with the door glass.
Yes, fellows, you do have to watch those window adjustments. But the engineers have made it a fairly simple job by providing for free movement of each window. For example, weather strip retainers on the front pillars and top side rails have elongated holes which permit movement of a 1/4 inch in or out. If the desired adjustment has not been taken up previously, place a fiber or wood block against the retainer and drive it over. When a good fit of windows to top side rails cannot be obtained by this method, the windows must be adjusted instead. The front pillar weather strip can be shimmed to make it parallel with the vent frame. You may have to make your own shim. Leave at least 2 holes in the shim for mounting it between the weather strip retainer and gutter. And don't forget to use sealer. Adjustment of the vent frame assembly requires removal of the door trim panel. To tilt the vent in or out from the top side rails, loosen these screws. Now, this will also let you tilt the forward edge of the door window in or out. Several window adjustments are locked in place by self-tapping screws. When these adjustments are changed, it may be necessary to drill new holes. To move the vent assembly vertically, first loosen the lower 3 screws shown and remove the upper 2. To seat the vent lower in the door, bend the upper division bar bracket up. Tighten the 3 lower screws first and then replace the 2 upper screws. To raise the complete vent assembly, place the necessary thickness of flat washers under the 2 outer screws in the upper division bar bracket. The rear edge of the door window can be tilted toward or away from the top weather stripping by moving the glass run. Loosen the nuts in the lower bracket and the run can be shifted in or out. It may not be necessary to move the division bar an equal amount, but if it is, remember that movement of the bar also affects the fit of the vent assembly. If adjustment of the glass run will not correct the window fit, additional movement can be obtained by inserting a shim between the bracket and the inner door panel. If the upper edge of the door window is not parallel with the top side rails, loosen the regulator screws. Shift the regulator assembly until the window is in line with the weather strip. Tighten the screws firmly. Next, loosen the upper glass run lock screw and move the run so that it is snug against the window frame without binding. Adjustments are provided for controlling the up and down travel of the door window. Loosen the screw in the upper stop and shift it so that the top of the window does not project above the top of the vent frame. Lower the window and loosen the screw in the lower stop. Shift the stop so that the window is even with the top of the door. Now, if necessary, relocate holes in both upper and lower window stops for self-tapping locking screws. Because it is hinged, more adjustments are provided for the quarter window than the others. To establish correct vertical fit of the window in the top weather strip, raise the window and remove the 3 large button plugs in the lock pillar face. Next, loosen the Allen screws under the plugs. Move the pivot bracket up or down about a 1/4 inch. Tighten the center screw to hold this adjustment and operate the window in both directions. Readjust if necessary to get a close fit without binding. Then hold the top of the quarter window against the weather strip. If it is parallel with the door window and fits snugly against the weather strip without binding when raised or lowered, secure the 2 lower bracket screws. If further adjustment of the quarter window is needed, remove the trim panel and loosen the 2 cap screws in the pivot bracket. Enlarged holes in the bracket flange permit shifting the hinge plate fore and aft or in and out. In addition, this adjustment makes it possible to bring the rear corner of the glass in or out from the weather strip. For example, when the rear corner is too far in, the curved edge of the window will override the weather strip. And of course, if it is too far out, it will not make a good seal. If the hinge plate has been moved in or out, it may be necessary to repeat adjustment of the 2 lower bracket screws in the lock pillar to correct the tilt of the window in and out. The quarter window guide has slotted mounting holes for correcting binding in this location. In and out adjustment of the guide can be made at the 2 upper holes, fore and aft adjustment at the single lower hole. As a final step in quarter window adjustment, remove the small button plug at the top of the lock pillar and adjust the stop screw so that the quarter window is parallel with the door window. When operation and fit of the top are shipshape, turn a weather eye on the condition of the fabric. This is important, both for appearance and long life. Cleaning at least every 3 months prevents permanent staining and abrasion. Dyeing restores color and prevents cracks.
Our first step in cleaning the top is to get rid of any loose dirt. If we didn't have a vacuum cleaner, you'd be hard at work with a hairbrush, my lad. Next, we'll mix up some Fomoco foam cleaner. The proportion is 1 part cleaner to 10 or 20 parts of water, depending on how dirty the top is. Now, dip that sponge in and keep squeezing it till you work up a good lather. Okay, you're ready to apply the foam. Use quick circular strokes, but be careful not to soak the fabric. Keep the sponge clean by rinsing it every so often in clean water and squeezing it dry before you go on. Finish up by rubbing the whole top lightly in the same direction. Now, clean up the sponge and wipe off the dirt and foam. Be sure the fabric is good and clean. Then dry it with a soft cloth. When it's dry, brush the top briskly in the same direction. For dyeing the top, it's best to use a spray gun, although you could use a good paintbrush. We're going to spray this one, so I'll thin out the dye with half as much lacquer thinner.
Okay, Fred, guess we're ready to start spraying. I've got everything covered up so we won't drip dye anyplace.
Well, spraying the top is just the same as spraying the body. Just be sure you don't soak the edges when you lap one section with another.
Say, here's a spot on the deck lid, Fred.
Well, let's get it off before it dries. A little turps will do it. Now, we'll have to wait 15 or 20 minutes before we can put on the second coat. Now, go ahead and park her in the lot, Art, until tomorrow. The sun will dry the top quickly, but we won't be able to fold it for at least a couple of days.
What lines, what looks, what perfect motion. That's my dreamboat.